Hello folks, we come back with the part 17 video, and here they tell us to show that this particular relation, that they ask us to take this relation, that is sin A plus B sin A cos B plus cos A sin B. Nothing new, we have studied this last year in the 11th standard in the trigonometry chapter. So they tell us that you take this relation and then using the fact that sin A plus B sin A cos B plus cos A sin B and the differentiation, obtain the sum formula for cos. Like cos, they say that you use differentiation and show that cos A plus B is cos A cos B minus sin A sin B. That formula you have to show. So we can use this, and we can also use differentiation, and we have to derive that formula. That's the question. Let's get back doing it. Since they say that we have to use this formula, we'll start from this formula itself. How? By taking derivatives on both sides. So that's what we are going to do. Starting directly from this formula, we are going to take the derivatives on both sides. So let's take the derivatives on both sides. D by dx of sin A plus B and d by dx of this particular thing, sin A cos B plus cos A sin B. Now this is a prod. This is d by dx of sin A plus B. So we all know that the derivative of sin is always cos. So it is cos A plus B. A and B are functions of x probably. So then in that case, you have to account for its derivative also. Always it's like that. If you have cos or some function and the variable or the function that is accompanying, if it may be derivable, you have to account for it. So that we will write derivative of A with respect to x plus derivative of B with respect to x. We are not clear now what is A and B. It could be a function, it could be just a variable, we don't know. So that is why we'll account for it. Now we'll go to the right hand side. In the right hand side, it's basically it's a sum of two functions, but internally they are variables also. They are products also. So let's see now how to take the derivative. It is d by dx of sin A cos B, first thing, and d by dx of cos A sin B. Now we'll take, because it's a product, let's take the derivative over here. Sin A derivative of cos B. So also cos B as it is, derivative of sin A. Similarly, cos A as it is, derivative of sin B. Sin B as it is, derivative of cos A. Now we'll actually find the derivative and see what comes. First part, it is sin A, so that stays as it is. Derivative of cos B, we all know derivative of cos B is minus sin B. We'll have to account for the derivative of B, so dB by dx. So also cos B as it is. Derivative of sin A, we all know, is cos A, and we have to account for the derivative dA by dx. Similarly, cos A as it is, derivative of sin B is cos B. We have to account for the B. Same way, we have sin B as it is, derivative of cos A is minus sin A, and that is dA by dx. We have to account for dA by dx. So now we will try to club these terms together. Let's have these two coming together. So what happens? We are having minus sin A sin B dB by dx. So also minus sin A sin B dA by dx. These two terms, it can be brought together. It becomes cos A cos B dA by dx plus cos A cos B dB by dx. Now it's very clear to us that these parts are common, so we can take it out. In the first case, let's take minus sin A sin B common, so that we are left with dA by dx from here and dB by dx from here by taking out common. Similarly, in these two cases, we can have the cos A, cos B common. So let's have the cos A, cos B coming out common. If cos A, cos B is common, then we are left with dA by dx plus dB by dx. When we look at both these terms, we further realize that dA by dx plus dB by dx is common in both the cases. So again, that can be removed out common. So you can have dA by dx plus dB by dx coming out common. So what remains in the bracket? You can have cos A cos B minus sin A sin B. Though this is first, we can write it later. It doesn't make any difference. So we are going to start from this step. Yeah, check from this step. We have started. We have reached here. So what have we got? We have got cos A plus B dA by dx plus dB by dx is equal to cos A cos B minus sin A sin B dA by dx plus dB by dx. That makes dA by dx plus dB by dx. It's easy to cancel. So let's have that cancelled, and that's how you get cos A plus B now becoming cos A cos B minus sin A sin B. And that's a cosine formula. So that's exactly what they asked us, that you use derive the cosine formula by using this formula, just by taking derivatives and being a little careful, like account for everything properly and then club up the terms, take it common and things like that. So that's all for this video. Maybe we will take the next problem. For the next problem, we can take up the next, we'll take it up in the next video. Thank you.